Lesson L020, AI Career Mastery. Welcome to Lesson 20, which is all about building a successful career in artificial intelligence. Whether you are just starting out or looking to advance an existing career, this lesson will give you a practical roadmap. We will cover career paths in AI, the technical and soft skills you need, how to build a portfolio, networking strategies, continuous learning approaches, salary expectations, and entrepreneurship opportunities. The AI job market is growing rapidly, and this lesson will help you position yourself to take advantage. Let us begin with the range of career paths available in AI. The field is much broader than many people realize. The machine learning engineer designs, builds, and deploys ML models into production. ML engineers need strong software engineering skills combined with deep knowledge of ML algorithms, frameworks like PyTorch and TensorFlow, and MLOps practices. The average salary for an ML engineer in the United States is around $155,000 per year, with senior roles at top companies exceeding $300,000. The data scientist analyzes large datasets to extract insights and build predictive models, requiring strong statistical analysis and data visualization skills. The median salary for data scientists is approximately $130,000 annually. Research scientists, often holding PhDs, develop new algorithms and publish academic papers. These roles are concentrated at major AI labs in top universities, with salaries ranging from $150,000 to over $400,000 at industry labs. Applied scientists bridge research and engineering, adapting cutting-edge research into practical applications. Another growing role is the AI product manager, who defines vision and strategy for AI-powered products. AI product managers need to understand technical possibilities well enough to make informed decisions, even if they do not build the models themselves. The average salary for AI product managers is around $160,000. More specialized roles include computer vision engineer, NLP engineer, robotics engineer, AI ethics specialist, and MLOps engineer. The AI job market has seen remarkable growth. LinkedIn reported that AI specialist job postings grew by over 74% annually between 2019 and 2023, and the World Economic Forum projects AI and machine learning specialists will be among the fastest growing job categories through 2027. The skills you need for an AI career divide into technical and soft skills. On the technical side, mathematics is foundational. You need linear algebra including vectors, matrices, eigenvalues, and matrix factorizations. You need calculus, especially multivariate calculus and the chain rule, which is the basis of backpropagation. You need probability and statistics including distributions, Bayes' theorem, hypothesis testing, and uncertainty quantification. You do not need to be a mathematician, but you need to understand these concepts well enough to read research papers and debug models. Programming is the next essential skill. Python is the dominant language in AI, and proficiency is required. You should know NumPy, Pandas, Matplotlib, and the core ML frameworks. Start with scikit-learn for classical ML, then move to PyTorch, which has become the dominant deep learning framework in research. TensorFlow and Keras remain important in production. You should also understand the MLOps ecosystem including Docker, Kubernetes, and MLflow for deploying models. Version control with Git is non-negotiable. On the soft skills side, communication is perhaps the most undervalued skill in AI. You need to explain complex technical concepts to non-technical stakeholders, write clear documentation, and present your work effectively. A common complaint from hiring managers is that candidates have excellent technical skills but cannot articulate their thinking. Critical thinking and problem decomposition are essential. AI projects often involve ill-defined problems that need to be broken down into manageable pieces. Ethical judgment is increasingly important. Employers want people who can think through ethical implications and identify potential biases before they reach production. Curiosity and intellectual humility are crucial because the field changes so rapidly. Building a portfolio is one of the most effective ways to demonstrate your skills to potential employers. In AI hiring, practical demonstrated ability often matters more than formal credentials. The most common way to build a portfolio is through personal projects. Choose projects that interest you and showcase different skills. A good portfolio might include one project in computer vision, one in natural language processing, and one in tabular data or time series forecasting. Each project should have a clear problem statement, a description of your approach, an evaluation of results, and well-documented code. Jupyter notebooks are great for exploratory work, but also include organized Python scripts to show production readiness. Kaggle is an excellent platform for building portfolio projects. Kaggle competitions provide real-world datasets and clear evaluation metrics. Even placing in the top 10% is a strong signal to employers. GitHub is essential for hosting your code. Make sure your repositories have clear README files that explain the project, how to run it, and what you learned. Contribute to open-source AI projects if you can. Contributions to libraries like Hugging Face Transformers, PyTorch, or Scikit-learn demonstrate that you can work with existing codebases. Blogging about your projects is another powerful strategy. Writing a clear technical blog post on Medium or your own website forces you to organize your thinking and demonstrates communication skills. A blog post that explains a complex concept clearly can be more impressive to employers than a resume bullet point. For research-oriented roles, publishing papers is the gold standard. Even without an academic affiliation, consider submitting to workshops at major conferences like NeurIPS, ICML, or ICLR, which have lower barriers to entry than main conference tracks. Networking in AI is more important than in many other technical fields because the field is still relatively small and relationship-driven. The single best way to network is attending conferences. Major AI conferences like NeurIPS, which attracts over 10,000 attendees annually, ICML, ICLR, and AAI are where the community gathers. When attending, prepare in advance. Identify people you want to meet, read their recent work, and prepare thoughtful questions. Do not approach people only asking for jobs. Engage with their ideas and build genuine intellectual connections. Smaller events like local meetups, hackathons, and industry-specific AI events can be even more valuable because the ratio of attendees to opportunities to connect is better. Online communities are also important. The AI community is active on Twitter, where researchers regularly share preprints and insights. Following and engaging with leading researchers builds your professional identity. LinkedIn is essential for professional networking. Keep your profile updated, share your projects, and engage with content from people you want to connect with. Reddit communities like r/machine learning provide technical discussions and job postings. Discord and Slack communities focused on specific AI topics offer more intimate networking. Finding mentors is one of the most valuable networking goals. A good mentor provides guidance on technical challenges, career decisions, and industry navigation. Do not be afraid to reach out to people whose work you admire. A concise, respectful message expressing genuine interest and asking a specific question is often well received. The key to effective networking is building genuine relationships rather than transactional connections. Give before you ask. Share useful resources, offer help, and be generous with your knowledge. Continuous learning is essential in a field that evolves as rapidly as AI. The half-life of technical knowledge in AI is estimated at only 1 to 2 years. The transformer architecture was introduced in 2017. GPT went from version 1 in 2018 to version 4 in 2023. Techniques like diffusion models, reinforcement learning from human feedback, and retrieval augmented generation have fundamentally changed the landscape. To stay current, you need a systematic approach. The most important strategy is reading research papers regularly. Skim abstracts of new papers on AR14 daily, and read deeply the ones most relevant to you. Tools like the AR14 Sanity Light app and Papers with Code help you filter and prioritize. Another strategy is taking online courses, but be selective. Identify specific gaps in your knowledge and fill them purposefully. Courses from deeplearning.ai, fast.ai, and MIT OpenCourseWare are high quality and frequently updated. Do not passively watch videos. Implement the algorithms yourself, work through exercises, and build projects that extend what you learned. Reproducing results from papers is one of the best learning exercises. Pick a paper you find interesting and try to implement it from scratch or using the author's code. This exposes you to all the practical details papers gloss over, from data preprocessing to hyperparameter tuning. Many successful AI professionals spend 1 to 2 hours per day on continuous learning, treating it as a non-negotiable part of their routine. Podcasts and YouTube channels can supplement your learning during commutes. Notable AI podcasts include the Lex Fridman Podcast, the Twiml AI Podcast, and Last Week in AI. However, passive consumption of audio and video is not a substitute for active learning through coding and implementation. Salary expectations in AI are among the highest of any field, but they vary significantly based on role, experience, location, and company. Entry-level ML engineers with 0 to 2 years of experience can expect base salaries of $80,000 to $120,000 in the United States, with total compensation reaching $150,000 at top tech companies. At the mid-level, with 3 to 5 years of experience, salaries typically range from $130,000 to $180,000, with total compensation at leading companies reaching $250,000 to $350,000. Senior engineers with 5 to 10 years of experience can earn base salaries of $180,000 to $250,000, with total compensation exceeding $500,000 at companies like Google, Meta, and OpenAI. Staff and principal level engineers can earn total compensation packages of $700,000 to over $1 million annually. Research scientists with PhDs and strong publication records command even higher premiums at top AI labs like OpenAI, DeepMind, and Anthropic, where total compensation can exceed $1 million per year. However, these are top-of-market figures. The median AI salary across all roles is lower. Geographic location matters significantly. Salaries in the San Francisco Bay Area, Seattle, and New York are highest, offset by high cost of living. Remote work has moderated some geographic differences, though many top AI roles still prefer in-person or hybrid arrangements. Salaries outside the United States are lower but still substantial relative to local averages. In London, a senior ML engineer might earn £80,000 to £150,000. In Berlin, €70,000 to €120,000. When evaluating compensation, look at total compensation rather than base salary alone. Equity, bonuses, benefits, and professional development budgets all contribute to the overall package. Entrepreneurship opportunities in AI are abundant and growing. AI startups attracted over $50 billion in venture capital funding globally in 2023 alone. The barriers to starting an AI company are lower than ever, thanks to open source models, cloud computing credits, and pre-trained models that can be fine-tuned for specific use cases. The most common AI startup model is building a SaaS product that uses AI to solve a specific business problem. Examples include Jasper AI for marketing content generation, Copy.ai for sales copy, and GitHub Copilot for code generation. These companies leverage large language models as a foundation and add value through domain-specific fine-tuning, user interface design, workflow integration, and customer support. Another model is building AI infrastructure tools. Companies like Weights and Biases, which provides experiment tracking, and Hugging Face, which provides model hosting, have built successful businesses serving the AI community. Consulting is another path. Many organizations need help implementing AI but lack in-house expertise. An AI consulting practice helps these organizations identify use cases, build proofs of concept, and deploy solutions. This path requires strong communication skills and business acumen. The key to successful AI entrepreneurship is focusing on a real customer problem rather than the technology itself. The most common mistake is building a solution in search of a problem. Successful AI startups identify a specific pain point for a specific customer segment and apply AI as a tool to solve it. It is also important to understand the economics. The cost of AI inference, especially with large models, can be significant and must be factored into pricing. Many AI startups have struggled because inference costs ate into their margins. For aspiring entrepreneurs, the best practice is to start with a narrow, well-defined use case, validated with real customers before building extensively, use existing models rather than building from scratch, and focus on the data moat, which is the unique dataset that gives your product an advantage over competitors using the same foundation models. As we wrap up this lesson and this entire course, remember that building a career in AI is a marathon, not a sprint. The field is vast, the learning curve is steep, and the landscape changes constantly. But the opportunities for impact, intellectual growth, and financial reward are extraordinary. The most successful people in AI are not necessarily the ones with the most raw intelligence. They are the ones who combine technical skills with persistence, effective communication, ethical awareness, and a genuine desire to solve meaningful problems. The skills you have learned throughout this course, from neural networks to ethics to career strategy, give you a strong foundation. Now it is up to you to apply them.